Here's some of my favorite people right here. We've got Grace and Natalie. How we doing, girls? There we
I'm
go.
good, Mr. Ainsworth. How are you?
I'm doing well. Thank you. All right. Well, as we get started here, we're going to check homework here first. So get out your last lesson, and we'll do a little Q&A, and then we'll launch a new activity here as well. Also, did you guys get my message about printing the next activity on 5E? Did you get that? Hey, Sophia, Matthew, Abby, how we doing? Did everybody get my message about printing the activity off for today? Because it's a new one. Okay. All right. It's in Canvas as well. Caden, how we doing, buddy? Your hair is getting bigger, man. How long are you gonna let it go?
I don't know, maybe till, I don't know. I'm just going to let it keep growing.
All right. Going back to like the 70s, back in the 70s, I don't know if you're familiar with this, but people had, they're called afros, the big ones, you could get to that. I have a student in my last class, his name is Jaden. I don't know if you know Jaden. He's another senior, but he's when he lets his hair go, it's getting out to here, man. It's funny. It's awesome. So we'll see how big it gets. Good morning, everybody. It's good to see everybody here. Start checking your homework from last activity here, and make sure you also have 5E activity, the next one here to print off. Make sure you printed that already because we're going to need it. It's in Canvas. I also send it out via Remind as well. So make sure you have printed that activity so you can participate today. It's our last big activity in section 5. Before we start the chapter review this weekend to get you guys ready for your test next week on Friday. So, oh, Talia, back at home. All right. Because you're at the cafe. How'd the cafe go yesterday? Or not yesterday, Wednesday. Did you guys have a fun time there?
Yeah, it was good.
Good. You might as well learn and have fun at the same time. Okay, so let me see. Let me go to Canvas real quick. Today's activity is 5E 1, 2, and 3. So let's go back to the main module here. So it's right down here, 5E 1, 2, and 3. Just open that page up and click on your link, and it's right there. So Natalie, are we good on that?
Yeah, I'm just printing it out real quick.
Yeah, that's good. Eli, go ahead and print. If you have to leave your room to go to your printer, that's fine. Just leave your cameras on and go and take care of the printing. And in the meantime, like I said, we're doing a little Q&A on your homework. So everybody correct your homework on 9, 10, 11. If you have any questions on that, let me know. Let's keep our cameras on at all times so I can see you guys and work with you guys. Carson, Austin, Gabby, Glider, all you guys, Tony, Nicole, Isabel, all you guys, Sayla, there you go. Good morning, everybody. Okay, so let me see. So as you correct your work, let's ask questions. We need to maximize our time here, guys, because it'll take at least an hour depending on your speed. So it depends on how fast you guys work with me and how fast you guys can calculate between your ears. No calculator exercises today, just unit circle work on the new activity here. So let's grade your homework here first. If you missed any or you're not sure how to correct it, then let me know. I'll explain any one of those. This is 5D1 part 2 that we did on Wednesday. And then I'll transition here to 5E here, the next activity in a minute. Make sure you guys have printed 5E. It's in Canvas. Last and final activity in section 5. Does anybody have any questions? Talk to me now. Just turn your mics on and go. Meaning start asking. Start talking to me. We need to use our mics more. I need to hear your voices. That's one thing that I really miss on this online experience is that I can't hear your voices all the time. You get to hear mine, but I don't get to hear yours all the time unless you speak up. How's everybody doing today?
Can you hear me?
Yeah, I can hear you, Gabby.
No, I just wanted to ask because I didn't turn mine in because like I was having a lot of trouble with it, and so I was like, oh, I'll just wait until we go over it. Can I still turn it in
Of course.
after we
And
go over it?
next time, let's make this because some semesters too, a little different schedule. We have what's called intervention in the afternoon instead of the 30 minutes after class. It is in the afternoon. So in the future, Gabby, you should message me either through Canvas or Remind, either one, because I get messages either way. Most people use Remind because I've been using that from day one. And say, hey, Ainsworth, can we meet at anytime between 1:30 and 2:30 typically, but if you need help later on, like, because I've met people at 5 o'clock p.m., 5 p.m. You just have to message me and ask to get together, and I will, we use the same Zoom link. Like today, we're going to go over the new lesson. You're going to have homework today on 5E, and you're also going to have a quiz on 5D1. So I'm putting it out there right now that if you guys have difficulty on either your homework that we covered today or your quiz that you're going to be starting after the class is done, then come during intervention and I'll work with you. You just have to
Okay.
request it.
I
Yeah,
just wanted to know if I could still turn it in. Okay.
Oh, of course. You can always turn in your homework late. I mean, I'll accept it. I'll look at it. No problem. But more importantly, if you need help, just come on in and I'll work with you, okay? And I'll help you with your homework. Okay, because that's what we do. That's my job, not just to teach lessons, but to help you out on the side. All right, so you guys please turn on your cameras. That's it's not a request. That's part of the deal. Everybody turn on your cameras every day, unless there is a specific reason. Private message me, but you can't do that all the time. You guys can only happen once in a while. And if there is a tech issue, you need to figure it out. So talk to your parents if you need to figure out the technology here. But I expect your cameras to be on every day. Okay. Let me just say that in general, out of all 5 of my senior classes, since I've been asking that during the second semester, participation has increased, student progress has increased, grades have gotten better because people are being more accountable. So I get your messages, Mark and Alex and a few others. So I understand that, but so talk to your parents, get that fixed. Okay, so having said that, let's get to mathematics. Here we go. This is your last activity on 5D1, part 2, the last 3 questions. So any questions here? This is what I came up with. Let's do a little Q&A first, and then we'll transition to the next activity. Be honest with yourself and me. Correct your work, and if you're not understanding my results, now's the time to speak up. We're quizzing later on today after the class, and we're testing on section 5 next week on Friday, just so you know. It's all up there on Canvas. If you haven't read all that and looked at all that, it's all up there. Okay, Amara, I got your message too. Talk to me, guys. Let's not waste any time here. Questions on 9, 10, or 11? If not, give me some kind of feedback in the chat or something, or verbally, one of the two. You got to be honest with yourself and me. Your results compared to my results.
For number 11, wouldn't the modulus be 6? Because 25, never mind. I'm done. Never mind.
No, well, you're not.
Never mind. I said my mistake.
Our connection's a little bit off right there, but you are not dumb. Okay, there's I totally disagree with that. We're all good. Sophia, give me a thumbs up if we're good. I assume that was Sophia. Yes. Okay. Now, Alex, what do you have
for number 11? Would it be 2 root 17 or is root 34 fine?
Well, okay, let's talk. I'm glad you brought that up. The factors are 2 and 17. However, if I rewrote it like this, root 2 times root 17, because 2 times 17 is 34. So that's what you have, but 2 and 17 are prime. Alex. And so because these are both prime, you can't simplify that. So I would leave it as root 34.
Okay.
I'm glad you brought that up, okay? Because I see that a lot. But 2 root 17 is different than root 34. You just leave it as root 34 because the factors are prime. So write down prime, cannot simplify. All right, good question. Any others? Okay, time to rock and roll. Everybody, let's go to 5E2. Here we go. Next one. New lesson here. Now, this was not in the notes that I printed for you guys in the beginning of the section here. It's a new lesson that I developed yesterday, so that's why I put it online. So it's right here in Canvas called 5E1, 2, and 3 activity. Just click on the link and print it, and you're good to go.
Sorry, my printer doesn't have any ink right now. Can I just do it on a separate piece of paper?
Yeah, that's what it says. If you cannot print, use graph paper.
Thank you.
So no worries there. So yeah, do whatever, use whatever you have there. Okay, so let's talk about the goal here first. This is a discovery lesson here. And our goal today is to learn how to multiply and divide complex numbers, not in Cartesian form, because you already know that. But you need to learn how to multiply and divide complex numbers in trig form. And it turns out it's really easy to do. And it's really useful in certain times. And so what we need to do is get all of these 4 complex numbers, Z1, Z2, Z3, and Z4 in trig form. So that'd be a good review for us to do. I'll go over all of the concepts again. And then once we get them in trig form, then we're gonna look at it all in summary. The summary's at the bottom. We're gonna put our results down there and we're gonna look for patterns. And we're gonna see how is it done, because it turns out to be extremely simple. But I'm not gonna tell you how to do it. We're gonna discover how to do it. Because that's the beautiful part about MRWC, is that it's a discovery process, you know, whereas in direct instruction, traditional pre-calc courses, you know, the teacher gets up there and just tells you how it's done. Well, in MRWC, we discover how it's done. So we do some mathematics, we explore mathematically, and then we look at all the results, and then we ask ourselves, how is it done? Okay, by looking at the results, because I'm not going to tell you. I'm going to ask you guys to figure it out. All right, so let's get started. Here we go. Get a pencil, red pen, and get some highlighters out so we can annotate in red. Okay, and get ready to participate. Give me a lot of energy today. All right, so Z1, our first complex number, is -1 minus I. So we have to graph -1, -1. Now use your fingers out there. Use your hands. What quadrant is that in? Give me a quick response on your fingers. What quadrant is -1, -1 in? That's not everybody. Come on, guys, participate. It's quadrant 3. You go left 1, down 1, you're in quadrant 3. All right, so I know that it's kind of hard, but these little marks right here, that's 1 unit in all directions. So we're gonna go 1 unit to the left and then 1 unit down. Okay, and that is Z right here, Z1. And the distance between the origin and the point itself is the modulus R. So let's label. And whenever you show theta, your polar angle here, you always start measuring from the real axis, measured counterclockwise. So draw theta correctly. It's always measured counterclockwise from the real axis. Okay, all the way to the point, okay? So now let's put some angles in. You always start at 0 degrees on the real axis, then go to 90, then 90 more is 180, plus 90 is 270. Put the angles in. And then if you add 90 to 270, you get a full revolution, or 360 degrees. So in polar angles, 0 degrees and 360 degrees are the same, believe it or not. Okay, so no calculator exercises today. So no calc needed today, although we could use it if you want to, but we don't need it today. We're going to be using the unit circle through this activity here. So let's talk modulus, polar angle, and everything. So first of all, tell me the triangle here. What kind of triangle are you guys looking at? Give me good vocabulary. What kind of triangle are you looking at? Because the side lengths are both 1. Which which hopefully it's familiar to you. This is a special triangle. Tell me the angles inside. Everybody chime in. Get involved in the chat. There we go. Good job. Let's write that out. That's really important. This is an isosceles right triangle. And the angles inside of it are 45, 45, 90. Very good. If I draw it big and bold up here, just draw it up here big and bold. You started learning about this triangle with me in section 3. We constructed the square root of 2. We constructed the square root of 3, 4, and 5, and all those numbers. And the way to construct this 45, 45, 90 is or to construct the root 2 is by constructing the 45, 45, 90 right triangle. We did that in section 3, believe it or not. So already, what do you know based upon what I just said? What do you know in this problem or for this complex number? What did I just kind of give away? Show me your understanding here, guys. Come on. What did I just give it away? Now, you told me that was 45 degrees. Inside the triangle is 45 degrees. That's true. Let me put that in there. Let's see if I can do that, if I can draw that small. Put 45 degrees in there. That's true. What did I give away, though, when I talked about the triangle? What's R called? What's the name of R? Let's talk vocabulary today. There you go. It's called the modulus. Okay, so the modulus is root 2 because it's a 45, 45, 90 right triangle. So here we go. So modulus R is the square root of 2. Although if you want to calculate it, you could do this. You could take the square root of -1 squared plus -1 squared. You could do that. You can do the arithmetic. But if you do that, you should get rad 2, and you do. So the square root of 1 plus 1 is 2. So you get R is equal to root 2. So really, we didn't have to use the formula for the modulus. We knew that it was root 2 because we know about special right triangles. Okay. Now let's talk theta. Let's talk polar angle. What's theta? Look closely here. You guys looking at the diagram? No trig needed, no calculator needed here. What do you think theta is? Because theta, it has to be between 180 and 270. What do you think it is? You guys can use your mics too, by the way. Okay, so it's 45 degrees past 180, which is 225. Do you guys agree with that? I can see you guys. You can give me head nods, thumbs up, down. You give me some body language here. Okay, I can see you guys here. All right, so theta, just by looking at the diagram here, it's 45 degrees past 180. So theta has to be 180 plus the 45, which I agree with you guys in the chat there. It's 225 degrees. It's a quadrant 3 angle. This is quadrant 3 down here. Okay. Now, having said that, now we know polar form. So let's get polar form and trig form. Here we go. So polar form. Well, what is? You tell me. What is polar? Well, yeah, what's polar form for this one? Come on, start using your mics, you guys. It's faster. Turn them on and off and just talk to me.
Is polar form r comma theta?
Yes, it is. So what would it be for this one?
It would be root 2 comma 225 degrees.
There you go. There we go. So root 2 comma 225 degrees. That's polar form. Now let's get trig form because this is what we need today. I'm reviewing everything, but the end result, the trig form is what we need. So Elia and Evan just agreed with you, Alex, there. So what's trig form? Who'd like to give that a shot? Volunteer verbally.
I'll do it. Okay, so it will be z equals √2 times cosine 225 plus I sine 225.
Very good. Thank you, Evan. All right. So let's highlight that because that's one of the end results that we need. We want to change all of these 4 complex numbers to trig form today. And then what we're going to do at the end, when we're done with the arithmetic, we look at all the results and we ask ourselves, what's going on? You know, how do you multiply complex numbers in trig form? How do you divide? So we just have to, we got 2 goals. How do you multiply numbers in trig form? How do you divide them? And it turns out to be simple once you have the results. All right, but we got to get the rest of the results. So here we go. Let's talk about Z2. Now Z2 is -1 plus I or -1 comma 1. Show me on your fingers, guys, what quadrant that's in. I'm looking at you guys. Not, guess, keep trying, everybody. Yeah, if you go left 1, up 1, you're in quadrant 2. Okay, so here we go. Let's graph it. So go left 1, and let's go up 1. Draw the modulus, or the distance from the point to the origin is called the modulus. R, radius, modulus, same thing. Okay, what do we already know based upon the first one? What do we know right now without doing any arithmetic? Use your mics, guys, come on. What do we know?
The modulus is square root of 2.
All right, what else do we know? That's correct.
Theta is, or some, the angles is 45, 45, 90.
Okay, it's an isosceles right triangle, that's good. So isosceles right triangle, and that means it's a 45, 45, 90. Which means inside this triangle lives a little teeny 45-degree angle here. But theta is different. Theta is between 90 and 180 degrees. It's an obtuse angle. Start calculating, start thinking, what does theta have to be? It's between 90 and 180 degrees. It's obtuse. There's 2 ways to get that angle. Show me the way, show me your methods. That's one way, Evan. Look at that. Okay, very good. So let's discuss that. So theta is not quite a half revolution. It's not 180. So you got to back up 45 degrees by subtraction. So that's one way. So the polar angle, which is called theta. One way to get it is to take 180 minus the 45 to get 135. Someone else said, 2 other people said 90 plus 45. I agree with that as well. So that's another way to get it. 90 degrees plus 45, which is also 135. Now, what's polar form? If you know the modulus and you know the polar angle, then you know the polar form. If you haven't joined in the chat, try to do it because the same people keep popping up, but you can't rely upon them. You gotta try to participate. You know, and if you make a mistake, no big deal. I don't care. I just care about whether you guys participate. Do you guys agree with Evan? You can give me head nods or whatnot. I'm looking at you guys right now. I have a big monitor in front of my computer. It's like, I don't know, a 27-inch screen, and it's you guys are big and bold right in front of me. Okay, so polar form is, you guys said √2, 135 degrees. That's correct. Okay, trig form. Who would like to give that a shot? Volunteer. Not glider. He took the last one. Out loud, just verbally.
Would it be root 2 times cos of 135 plus I sine of 135?
Very good, Natalie. Thank you. Okay, so let's highlight that because that's an important, we're going to need that result. Okay, so now let's take a look at the product. What Z1 times Z2, that is called a product. Okay, so what we're going to do is we're going to multiply the two complex numbers that we just worked with. Z1 times Z2. Now these are binomials, so what algebraic technique do we use when you multiply binomials? Going back to algebra 1. FOIL, okay. Or distributor property, either one. Okay, I want you guys to do that ahead of me. I want to see what you guys get, and then I'll work it out. Take a moment and work ahead. Multiply those binomials. What do you get? Let me know what you're getting. Yes, you could Glider, you can also use structure. And because this is A minus B times A plus B. So if you wanted to use structure, A minus B times A plus B, you could use the difference of squares. So if you want to do it that way, go for it. Good eye, by the way. Work ahead of me and tell me what you're coming up with. Okay, let's see if 2 is correct. So I'm going to work it through. So just -1 times -1 is 1. -1 times I is negative I. -1 right here times, excuse me, negative I times -1 is positive I. And then -1, excuse me, negative I times I is negative I squared, or minus I squared. So remember, in complex numbers, I squared is always -1. Okay, always. So in the middle here, these cancel out to 0. A negative I plus I cancels out to 0. And so I see 1 minus this -1. I squared is -1. Remember that. And so I see 1 plus 1, or 2. So I agree with you. The Z3 is equal to 2. That's the product. Now, what order pair do you graph in order to graph that? How do you write 2, which is just real, with no imaginary part? How do you write that as an order pair? This is the same thing as 2 plus 0i. So the 0i canceled out to 0, but I can write 0i here if I want. Okay, I agree with that, you guys. 2 comma 0. So let's graph 2 comma 0. Is that on the real axis or the imaginary axis? Which one? Okay, 2's real, so it's going to be on the real axis. So here we go. So I'm going to plot it, approximate. It's a little bit off the grid, so just go ahead and approximate it. There's Z3. It's on the real axis. Okay, so now that we know that, the origin's here. Origin's here. Z3 is 2 units to the right. What do you know? Just by looking at the diagram, what do you know? Talk to me, guys. Come on. What do you know? If it's 2 units from the origin, what do you know? without doing any arithmetic. You're just looking at it. Good, Brianna. Okay. Carson agrees with you. 2. What does that represent? What's the name of it? Okay, it's called the modulus. So because of that, you know that the modulus, which is the distance from the origin to the point, r is equal to 2. What's the polar angle? What's theta equal to? Okay, so let's label the graph here. So on the real axis, when you start rotating, you always start on the real axis, which starts at 0 degrees. So in red, 0 degrees. Up the very top, 90 degrees, and then 180, and then 270, and then you're right back to the real axis again. So 0 degrees is the same thing as 360 degrees. So the polar angle could be thought of as 0 degrees, or it can be thought of as 360 degrees, or 720. You can just keep on rotating 360 and you get right back where you started. I mean, just think about it. Rotate all the way around, you're at the same spot. Rotate another 360 plus another 360. There's an infinite number of angles that are the same as 0 degrees. When you graph in polar, believe it or not, there's not just one answer for the polar form. There's an infinite number of ways to represent the same point, which is weird, but it's new. Okay, so what's polar form? Which is r comma theta. I'll take a volunteer on that. What are the 2 ways we can write this based upon what we've talked about already? What's polar form? Go ahead.
2, 0 degrees and 2, 360 degrees.
Very good. So 2, 0 degrees and 2, 360 degrees. Good job, Austin. Okay, now let's get to trig form. This is what we need today. I'll take a volunteer. Someone that has not offered on the trig form yet. I need someone to stand up here and be a bold, brave, courageous mathematician. Let me know what trig form looks like. I need a bold, brave, courageous young mathematician to volunteer. I need a bold, brave, courageous young mathematician to stand up and let me know how to do this here.
Would it be 2 cosine 360 plus I sine 360?
That's correct. And then what's the other possibility here? So
0.
okay, so hang on. Say the other possibility out loud.
2 cosine 0 plus I sine 0.
There you go. Thank you. Good job. That was Gabby, right?
Yes.
All right. Nicely done. Okay, so let's highlight that. All right. Now, the last thing we need to do is take a look at the quotient, because we need to figure out how do you divide numbers in complex form. How do you do that? I mean, and it turns out to be really simple if you know. So we need this one here, Z4. So this is called a quotient. When you divide 2 things, it's called a quotient. All right, but how do you do that? This goes all the way back to, the beginning of section 5. From last semester, we talked about this. We started off the section 5 with basic skills. This is one of them. What do you do? How do you handle this? Because this quotient here, -1 minus I divided by -1 plus I, is not in Cartesian form. So what do you do? This is good review too, because this is on the test next week. All of this is, okay? Now, do we use the conjugate of the numerator or denominator? Be specific. Do we look at the denominator or the numerator? Top or bottom? The conjugate is correct. We need the conjugate, but the conjugate of the numerator or the conjugate of the denominator? And that's correct. Okay, so here we go. In red, get your red pen out. Let's multiply by the conjugate of -1 plus I. Oh, stop right there. What's the conjugate? Let's see, I forgot. Ainsworth forgot. Help me out. I'm having a senior moment. I've had some senior moments today, guys. I've made silly mistakes. Does it ever happen to you where you just do like a silly error all the time? Like you have one of those days where you keep on making silly errors, silly mistakes? Because I'm having one of those days. So Natalie, it happens to you once in a while? Guess what that means? It means you're human. Because we all make mistakes, you know? And Ainsworth has made a lot too many today. I usually pretty on, but today I'm having a rough time. So let's see if I can get through period 6 with no mistakes. So here we go. Here's the conjugate, -1 minus I divided by -1 minus I. Now these are binomials. So we have to use FOIL again. Here we go. Now, everybody work on the numerator. Work ahead of me. Let's do the numerator first. Work on the numerator and then stop there and tell me what you're getting. Distribute through and just focus in on the numerator right now. Let me know when you're ready. Don't worry about being right or wrong. Just participate. What are you guys getting for the numerator?
Would be 1 plus I plus I plus I squared.
Okay, let me write that out. So 1 plus I plus I plus I squared. I agree with that. We have to simplify that. Can someone help out with simplifying here? When you add all those things together, remember I squared is -1. Be careful there. That was correct. What do you get when you simplify? Good job. Okay. So that's going to become 2I because the I squared is -1. So I squared is -1. I'll put it equals -1 here. And when you add -1 with the other one, like these two terms right here, they cancel to 0. Okay, cancel. They equal to 0. -1 plus 1 is 0. So you get 2I up top. Now, you guys look closely. The denominator, we should already know. The denominator happens to be Z3 above. We already did it. Do you guys see that? Let me highlight here. I'll put it in green, I guess. Okay, so watch, look at right here. These are the same, aren't they? Aren't those the same? Yes or no? Come on, come on. Are they the same? The order may be different, but they're the same. So what's the denominator? Show me your fingers. Okay, we already calculated in Z3. We know it's 2. So the denominator is 2. No need to distribute. Use your prior results. Okay, so let's finish. So we got 2I up top. We got 2 down below. What's 2I divided by I? What's that, Sayla? Yeah. I think I heard you. I was trying to read your lips. Did you say 1 or I? I or 1?
I.
There you go. All right. Thank you. Okay. So how do you write that? What do you graph? What order pair do we graph? 0, 1. So that, my friends, is up there on the imaginary axis because that's imaginary. Okay, so here we go. So here's Z4 on the graph. Here's the origin here. Okay, so there's Z4. And remember your angles here. I'm going to put the angles in. You always start off on the real axis at 0 degrees. And you go up here at 90 degrees, then 180, and then 270, and then right back to the real axis again at 360. So you know a bunch of stuff. So let's start off with the modulus. What do you guys see? What's R? You can show me on your hands, by the way. Give me quick responses here. What's the modulus? I'm only getting a couple responses here on your hands. Okay. It's 1 unit up from the origin. The modulus is always the distance from the origin. So the R has to be 1. What's the polar angle? Polar angle theta. What do you guys see in the diagram? Okay, so Gabby's responding in the chat right there. So she's already going to polar form. Carson agrees. So it's at 90 degrees. It's up there on the imaginary axis, 1 unit up. So there we go. Polar form is already, we already know polar form as well. And that's always R comma theta. So for us, it's 1 comma 90 degrees. Okay, so now the only thing we need is trig form. And then we could start summarizing everything here. So I need someone to take this. What's trig form? Need a bold, brave, courageous, young mathematician. Volunteer. Come on, guys. Someone help us finish up here.
I can go, but I don't know if you want someone else to go.
Oh, it doesn't matter. You can participate. Go ahead.
1 cosine 90 plus I sine 90.
Okay, very good. Okay, so there's trig form for the last one here. Thank you. All right. So what we need to do is summarize these results, organize these results. So at the top of the screen is Z1. And then we have Z2, and then we have Z3. So Z1, Z2, Z3, and the fourth one is Z4. Here we need to take all these and write them in the table. Okay, you don't need me for that. Just write them down. And you're gonna have to write kind of small because the table's not too big. So just write really small. So Z2 or Z1 is root 2 times cosine of 225 plus I sine of 225. It's gonna help you to see the patterns when you organize it in the table. Z2 is root 2 times cosine of 135 plus I sine 135. And then the product, Z3 is 2 times cosine of, put the one down with 360-degree angles, not the one with involving 0. So I know there's 2 variations of this, but write the one with 360 in it. You'll see why here in a minute. And then the last one here, Z4, let's write down here or down below. Z4 is 1. Make sure you put the 1 too. You'll see why here in a minute, because you're going to need to see that there's a 1 there. And the way you see it is by writing it down. So, okay. So you just transfer down your answers down here in the table. And then what we're going to do is what all mathematicians do is that after you do a lot of calculating, and again, this is what mathematicians did a long, long time ago. They explore through a bunch of mathematics and they see patterns. And when you see patterns, then you generalize the patterns. And you generalize them in words and then mathematical. And then hang in there, Katie. And then after you generalize them in words, you have to prove them mathematically. And the proof of this, it's a little beyond the course. I could show it to you later on if you are curious. But there's a couple things that are involved in the proof that you don't know about yet because we don't have enough trig background yet. So the proof is kind of difficult because some of the elements of the proof you don't know about. All right, so what we're going to do is just generalize them in words and then apply it. I'm not going to prove this theorem here for you guys today. Okay, so let's figure out what's going on. The goal in this lesson was to figure out how do you multiply numbers in trig form. So everybody stop what you're doing, look at my screen because I'm going to color code things. And then we're all going to generalize the results in words. Okay, so everybody, let's look at the moduli first. So this is in yellow. The first modulus is root 2. Look on my screen. The second modulus is root 2. And then we multiplied them. This is the Z1 and Z2. This is called a product now. When you multiply the end result, the modulus is 2. It changed to 2. So let me repeat that. Look in yellow now. The first modulus is root 2. The second modulus is root 2. But when you the modulus in the result is 2. So what pattern do you see in the moduli? What do you do with the root 2's to get 2? You add, subtract, multiply, divide. What do you do? What do you do to rad 2 or root 2 and the other root 2 to get to 2, which is a whole number? Do you guys agree with Gabby and Carson? Do you see that? Is root 2 times root 2, is that just 2? Is that true or false? Guys, give me some body language out there. Thumbs up, down, head nod, something. Tell me that you're thinking either you're understanding or you're not, one of the two. Or go to the chat like some people are doing right now. Okay, so look here. Root 2, whoops, not Z. Root 2 times root 2 is equal to 2. So all you have to do is, like, when you're multiplying complex numbers in trig form, you just multiply the moduli. Remember, moduli is plural. Modulus is singular. So you multiply the moduli. But what do you do to the polar angles? Now that is different. Okay, so I'm going to switch colors. I'm going to switch to blue highlighter. So everybody look at the screen. I'm going to highlight the angles now. Look at this. The first angle is 225. The second angle is 135. And then after you multiply the complex numbers, the new angle is 360. What in the world is going on there? What pattern do you see in the polar angles? Right here, what pattern do you see in the polar angles? Okay, so is 225 plus 135, is that equal to 360 degrees, true or false? Is that true or false? I can see a couple. Okay, some of you guys are agreeing. And of course it's true. You can check that. Okay, so what you do is you add the polar angles. All right, so let's go to the key ideas. This is the culmination. This is what we did all the work for. So when multiplying complex numbers in trig form, okay, let's summarize here. You multiply moduli, multiply the moduli, and add the polar angles. That's the key concept of today's lesson right there. And again, whenever you're in a math class, or actually any class, but especially mathematics, whenever you come up with a key idea like that, the main idea, you do all this math. We did a ton of math earlier, arithmetic. You really got to focus in on this right here. This is what you have to know. This is what we did all the arithmetic for. All right. Now, when you divide complex numbers in trig form, that's different. Okay, so let's go back up to the table and let's figure this out, because this is different. Okay, get your eyes on the table again. Look in yellow. Okay, I got to highlight again. So the first modulus is root 2. Look in yellow. The second modulus is root 2. But in the end result, the end modulus is 1. So when we divided these complex numbers in trig form, we got a modulus of 1. So what do you do with root 2 and root 2 to get a modulus of 1? Do you add, subtract, multiply, or divide? What do you do? What do you do with the moduli, the root 2's, to get 1? Okay, so let's write that down. So root 2 divided by root 2 is equal to 1. So you divide moduli. That's all you do. And that's something you can do in your head. Well, unless it gets really complicated, but we're not going to get that complicated. Okay, but you divide the moduli. Now, something different happens with the polar angles. So let's go to the angles. So get your eyes in blue again. So here we go. Let me switch to blue highlighter. Okay. So the first angle is 225. The second angle is 135. But after you divide the angles, or the numbers, excuse me, the angles, we get after you divide the numbers, the complex numbers, you get an angle of 90. So what do you do with 225 and 135 to get the 90? Good job, Mark. Okay. All right, there we go. Carson backs you up on that. So let's check that out. So let's write it out. 225 minus 135 is equal to 90 degrees. So you subtract polar angles. All right, so let's put those two together and let's finish our key idea. So number 2, when dividing two complex numbers in trig form, okay, you divide moduli and subtract polar angles. This is what we did all the work for today. This to understand this right here. I could have told you in the very beginning, you know, in traditional math classes, that's all they did. They just said, state the theorem and they apply it, but you never understand why it works. And that's the problem with the traditional class, is that you really don't get the derivation. You don't do all the discovery process. And that's what MRWC is all about. You discover it versus me just telling you how everything works. Okay. And that's why I like the course. Okay. Because I teach all the courses, but this one's my favorite to teach because it's all discovery based. Let's go to the next page and let's apply it. Okay. So we are not going to be using the calculator here. So no calculator. Use only the unit circle, no calculator. So keep that in mind. I'm not going to give you guys calculator examples here. You guys need to know how to use the unit circle. And if you didn't touch the unit circle at the end of last year, you know, when we went on emergency leave, when we went online for the first time ever in education, then you better listen closely because you have to learn how to use the unit circle. So I'm going to go over it again. Okay. I did it in a couple videos, but I'm going to do it live with you here today. So let's go down to our main example. The first one's multiplying, the second one's dividing. Okay, so we have two complex numbers up here. We have Z1. Second complex number, we have Z2 right here. We're going to multiply them first, and then afterwards we're going to divide them. Okay, first step in any problem, you got to write it down. Okay, so here we go. So Z1 times Z2 is equal to the one in yellow up there, 8 times the cosine of 135 plus I sine of 135 times, put the multiplication symbol there, 2 times cosine of 15 degrees plus I sine of 15 degrees. Now, if you didn't know what we just learned, you would have to use a calculator to solve this problem. But knowing what you just learned, you don't need a calculator. So again, no calculator needed here because we know something. Because right now, cosine of 15 degrees, that doesn't exist on the special rights. So you need to know what we just learned right there. Okay, so let's do some, let's apply what we know. So the very first step is you multiply the moduli, which are 8 and 2. So next step, I go 8 times 2. And then the next step after that, after you multiply the moduli, 8 and 2, which will become 16 here in a minute. All right, you got to take a look at your angles, okay? And your angles are 135 and 15, so I've got to add them up. So I'm going to rewrite this as cosine of 135 plus 15. Notice I'm adding right there. Plus I times the sine of 135 plus 15 degrees. So let me highlight what I just added the angles 135 and 15. Now experienced, when you get experienced, you know, you don't write it step down. You do all that in your head. You multiply 8 times 2 in your head and you write down 16 instead. You add 135 and 15 in your head and you write down the result. But I'm teaching here, so I step everything out so you know what's going on. So 8 times 2 is obviously 16. But what do you get when you add 135 and 15? Help me out there. What are you getting? Okay, so 135 and 15 is 150. So you get times cosine of 150 degrees plus I times the sine of 150 degrees. The question is, what is that? No calculator. Okay, we want to use unit circle. The calculator will not give you the exact answer, but the unit circle will. Okay, so if this is new for you guys, if you're not strong and you fully don't understand the unit circle, then really pay attention here. Okay, I broke the unit circle up into 2 parts. On the left side of the screen are just the angles that are multiples of 45. Okay, 45, 90, 135, 180. Those are called multiples of 45. On the right are multiples of 30, 30, 60, 90, 120, 150, 180, and so on. And I broke it up, the unit circle up into 2 parts to make it a little bit easier to see because the unit circle is complicated. I mean, be honest with me. Last year when you first saw it, who thought it was complicated looking? When you first see that thing, it is gnarly. Okay, and I understand that. Okay, so I broke it up to separate the angles to make it easier to look at. Okay, so we want to figure out what in the world is cosine of 150. So here we go. Let's look on the second one here. The angle 150 is in quadrant 2. Okay, on the unit circle, listen closely now if this is new to you. The first coordinate is always the cosine of the angle. So just by looking at this, I know that the cosine of 150 is negative rad 3 over 2. By the way, I just wanted some feedback because I don't know what happened in your education last year at the end of the year. Who studied this and who knew that who knows what I'm talking about? The cosine is the first coordinate and the sine is the second coordinate. Who already knows that? Nicole, Austin, keep your hands up. Caden, I just want to see how many people have seen this. Okay, a few, but not many. Okay, so now the next one, the sine of the angle, the sine of 150 is the second coordinate. The cosine is always the first coordinate. The sine is always the second coordinate. So the sine of 150 is 1/2. You can verify all this with Desmos too, by the way. You can just plug it in Desmos and it'll give you the same thing. Okay, now let's use it. Here we go. So the cosine of 150 is the negative rad 3 over 2. So 16 times, negative rad 3 over 2 plus I times the sine of 150, which I said was 1/2. Okay, there's the unit circle work right there. Okay, now distribute through, finish up. You guys finish up. Distribute through the 16 and tell me what you're coming up with. Work ahead of me. Let me know what you're coming up with when you're ready. Comment on what Glider said up there. Agree, disagree, not sure. I see you, Austin. Caden. Okay, when you distribute through, 16 times negative root 3 is negative 16 root 3. But you got to divide it by 2. Plus 16 times I times 1 is just 16i, and you got to divide that by 2. So when you divide the 16s by 2, you get negative 8 rad 3 plus 8i, and that is Cartesian form. So I agree with you guys. Glad I agree with that. Okay. That's an example of how you multiply complex numbers in trig form. And my friends, if you didn't know that, if you couldn't have done this because you have no idea what cosine of 15 degrees is. You go look out on the unit circle, it's not on there. And I said no calculator. So these results that we found on the previous page, all the summaries here, the key ideas, this really comes in handy, and it really comes in handy later on doing more advanced stuff. All your resources are going to be allowed on the test on Friday. So note, it's an open note, open activity, any resource you want, have it all organized on your desktop and use it to your advantage. And there will be some calculator exercises too. So Desmos and the TR-84 are allowed, but Glider, all resources. Okay. All right. Let's finish up. Here we go. This is how you divide. And is it, you know, with anything, you gotta, the first step to learn it is by writing it down. So let's write it down. So Z1 divided by Z2 is equal to 8 times cosine of 135 plus I sine of 135 divided by 2 times cosine of only 15 degrees plus I sine of 15. So the first step, you write it down, okay? So what does your gut instinct say? What should you simplify first? Use your mics, guys. What should we, okay, but what, Natalie, go ahead and speak up. What are you doing?
You divide the 8 and the 2 together to get 4.
What do the 8 and the 2 represent?
They represent R.
What's
Is
that
that
called? What's
the
the name? Yes. Okay, so you divide the moduli. So she divided 8 by 2 to get 4. So that's this part right here. R1 divided by R2. You divide the moduli. 8 divided by 2 is 4. Okay, so I'm going to write that out. So it's going to be 4 times something. Okay, step 2, you subtract the polar angles. And we've got 2 polar angles. They're called 135 and 15. So we take cosine of 135 minus 15 plus I times the sine of 135 minus I, excuse me, minus 15. That's subtracting the polar angles, theta 1 minus theta 2. The question is what do you get? So help me out. Okay, there you go, Mark. Mark's working ahead here. Here we go. So 135 minus 15 is 120. So we get times cosine of 120 degrees plus I times sine of 120. Very good. This is where you use the unit circle. Okay, so what we need to do is we need to go up to the unit circle and figure out what the cosine of 120 is and what the sine of 120 is. Because if you don't have this stuff memorized, which most people don't, which is okay. I said you get to use your resources. You use the unit circle. So you should definitely have that on your desktop all the time when you're doing your work. So we got to find 120 degrees. Okay, so the cosine, look right here. The cosine comes first. It's the x coordinate, and the sine is the y coordinate. So when I look at 120, which is in quadrant 2, (1/2) represents the cosine of 120. And then the √3/2 represents the sine of 120. You guys, does that make sense to you? Be honest with me here. The cosine of 120 is the first coordinate, (1/2), and the sine of 120 represents the second coordinate, which is √3/2. Those are the two fractions that we're going to bring down and use. Notice that we're not using the calculator here. So this is (1/2) plus I times √3/2. Now go ahead and work ahead of me and let's finish strong here. Distribute. What do you get? Well, the good thing is Natalie and Carson and Abby agree. Oh, by the way, Abby, I probably asked this before, but what kind of keyboard are you using to get a √3 symbol or a root symbol on that?
I don't know. I just press Alt V and it gives me it. I like randomly found it and I was like, oh, that's cool. So
Alt B.
yeah.
Well, since we use roots all the time, that comes in handy. Everybody write that down. Thank you, Abby. Okay. So here we go. 4 times (1) is (4), divided by 2 is (2). And then 4 times √3, or 4 times I times √3 is 4i√3, but you got to divide that by 2, so you get (2) plus 2i√3. That is in Cartesian form. Okay, so we did an example with multiplication, which is the first example, and then we did an example with division. Let's pause here. Any questions up at this point? Giving you guys time to reflect, finish your notes, and ask questions here. Okay. All right. Now, you just have 3 homework problems. Finish 2, 3, and 4. So this is homework. This is on your own. This is due tonight. You can do it right now and finish it. That'd be great. And then scan and submit. And then we will, on our next session, we'll cover the answers on this and make sure it's all good. If you have, if you need help on this, remember intervention today and write this down somewhere on your desktop. Intervention is for you guys. It could be any day of the week if you ask for it, but MRWC has priority Wednesday, Friday from 1:10 to 2:30. MRWC has priority, but if you have questions on Tuesdays or Thursdays, all you have to do is contact me via Reminder Canvas and request a, just an intervention, a little get together, and we can Zoom using the same link that we use here. And I can help you out with the homework, test prep, and all that. And that's really going to come in handy next week, because next week on Friday is your test. And you should put that on your calendar right now. Next week, Friday, is your Section 5 test. Interventions could be used for test prep, extra help, all of that. So you guys just have to show up, and you just have to request it and show up and meet me, and I will do everything I can to help you get prepared for the exam on next week. Let's go to Canvas. And let's take a look at what I have prepared for you. Everybody follow me on your Canvas here so you see. Okay, so first thing, your quiz today is right here on the last activity, 5D1. There's a quiz that's available. Let's just open it up and let's just take a look at each one here. I teach 3 MRWCs. Periods 4, 5, and 6 are all MRWC, and you guys are all linked together. That's why when you log in, it looks like period 4, but period 4 is the home period, and then periods 5 and 6 are attached to it. They're all one big MRWC program. I changed that this semester. It's called cross-listing, but it's a way for me to push out pages and materials and resources to all 120 MRWC students instead of like repeating myself for 3 different classes. So make sure you click on period 6. Do not print off the wrong test. You'll get a 0 there. Print off version 3 for you guys. You can do that after school today when we're done. That's due tonight at midnight, as well as your homework, because over the weekend, I want you to start the section 5 review. And successful students do things over time. So you get your homework done and your quiz done, which are fairly short. It's probably about a 20-minute quiz max. I don't expect you guys to take longer than that. And your homework should take anywhere from 10 to 15 minutes. So this is easily done by midnight tonight. Go ahead and click next with me. This is where you submit your homework when you're done. So whenever that happens today, scan and submit it up through here. And then here's your review. This is your section 5 test review. Notice it says tests next week on Friday, January 29th. It's 7 days from today. And you have your review. So everybody hold up your notes that you have right now. The ones I printed from you for you guys for the section. Hold them up. Let me see them. Now go in the back of that. Tell me what page the section 5 review starts on. What page is the section 5 review? Theme 1, section 5 review. Okay, page 41. So you guys have it. Now, if you guys didn't pick up a copy of all your notes, then you just click on this right here and the link right here and it pops up. And it's pretty extensive. It goes all the way back to the beginning. And I didn't put up my solutions to this. So this is what I want you guys to do. So, and it's very important that you check your work as you go. And, you know, it surprises me that people don't know this. So I'm going to talk about this. I like your pup, Grace. What's your pup's name?
Chandler Bing from Friends.
He's a cutie. All
Thank
right.
you.
So the way you check with the video is you open it up first of all. Okay. So I'm going to do that. Hang on. There we go. And let's start it from the beginning here. And because it's a video, you're not going to need to watch the whole thing. In fact, you're only going to need to watch whatever you're weak on. Okay. But the way you check it is just by simply advancing it. So you advance it like 5 minutes. So it advances right here and you pause it and check it out. You get the answers right here. So since you guys are looking at your section 5 review right now, get your red pen out and put a couple things at the very top. Write this down in red at the top of your section 5 review. First of all, write down video in Canvas. Okay, that's first thing. You guys should be writing right now. Everybody should be writing right now. Okay, second thing is you need to check your work with the video. Write that down. Check work with video. All you do is advance it, you know, a few minutes, and then you look at the screen and you can get the solutions by advancing it. And I'm just surprised that more people are not using the videos in this fashion to check their work. And I know that not everybody's doing that because you guys, some of you guys are turning in work that, you know, where some of the things are incorrect, which means you're not checking and using the videos. So one of the important things that you guys need to remember with test prep is that number one, you got to do the review, but more importantly, you got to do it right. And because, you know, if you do it incorrectly, you're going to do it incorrectly on the test. So checking your work with the video is so important. And you don't have to watch the entire video because it's like an hour long. All you do is advance and check, advance and check. Give me a thumbs up if you're understanding me here. Because I'm not asking you to watch the entire video. I'm not doing that. I'm just asking you to use the video to check. Although if you need to watch the video, obviously it's there. And you need those kind of resources because we're not at school right now. You can't just come in during lunchtime and sit down with me and get help. You can't come in after school and sit down with me and get help. So I'm giving you help virtually here. And that's why I've been producing and uploading all these videos for you guys so you can get help no matter where you are. Because I have students in Egypt right now, if you can believe that. I have a student in Egypt. He lives near the pyramids. And he's keeping up with me all the way halfway around the planet. So no matter where you are, you can do well, as long as you use your resources properly. Okay, and that's it. Any questions or needs before I let you go? Okay, well, I thought you did really well today. I'm proud of you guys. So leave me with a big smile. You guys have a good one here. Have a good weekend. And I'll see everybody next week. Unless you call me and then we can request meeting up with me, okay? And remember, we have intervention if you need it. Okay, I'll see you guys. Good job. What's up, Austin?
Okay, so I'm not gonna have an available printer till tomorrow, right? So for the quiz,
Say that again, please.
I'm not gonna have an available printer till tomorrow, right? So for the quiz, can I just copy it down on a separate piece of paper and do it on there?
Oh, of course, yeah.
Okay.
And let me bring it up for you because that'll be really easy for you to do. So I'm going to open it up here in front of you. Even though it's not available, I'm going to do it. Let me see here. I could do it. It looks like this. And so doing that on a piece of graph paper would be easy.
Okay, thank you. Also, I know we have homework as well. Will I be able to access it on my computer? Because the pages, like, is it a part of like the big thick packet of notes that I printed a long time ago, or is it the thing that we?
Today's activity here was new. Let me bring it up. So that's why I had everybody print it off. So it's 5E right here. You just open this up. So were you just taking notes today on a piece of graph paper or something?
Yes, like all of this I did on a separate piece of paper.
Yeah, that's fine. Okay, so all you have to do is just continue and write these problems down. Just physically write them down right here and work them out, scan and submit, and everything will be okay.
Okay, cool. Thank you.
No worries, man.
All right,
Listen, have
bye.
a good weekend, and I'll see you soon, okay?
Yeah, you too.
All right, thank you.
Bye.
Bye-bye.